Right. Hey, everyone. Don't you wish that in real life, right, you take a remote, like a clicker, and you press a button and things just start moving, right? But it doesn't really play out that way, especially when you move that to tech, right? You want your infrastructure to just work. And a lot of times we see that with infrastructure that we adopt, we tend to also pack on a lot of things that we need to learn about the infrastructure so that we understand how we can, manage it better and also, avoid sleepless nights. I'm Fuzz. I'm a senior developer advocate at Amazon Web Services. I'm here from hot and happening Dubai, and along with me sharing the stage is Thiru.
Hi, everyone. Good morning. My name is Thiru. I'm a solutions architect with Amazon Web Services as well. I'm based in Copenhagen in Denmark, but I'm originally from Malaysia. So looking forward to this presentation to all of you.
Sweet. Right, so this frustrated on-call manager, I'm sure me and Thiru over here, we definitely share this story, and maybe some of you in the room already have gone through this, right? And it's not anything new, right? It's any kind of technology that you adopt that you kind of question sometimes your choices, right? Even if you've been using it for years. And the reason we see this happen a lot is that the understanding of the technology matters, right? How it works, how it functions, beyond just product descriptions, beyond just data sheets. With Kubernetes especially, this comes to play when you kind of start realizing, right, from an architecture perspective, there's more to it than just creating a cluster somewhere and then deploying your apps and it's all done. As a developer, I would love that. I don't have to worry about it. But then for whoever's managing the cluster, there's a lot more, right? You have the control plane, you have the data plane, you have the nodes, and there's a lot of things happening in between that could go wrong and will go wrong, as you'll see in our demo-filled session up next. So today we're going to be talking about common failure scenarios. We're going to be talking about what's your understanding of failure? How do you actually want to start understanding that and processing it? What are the steps that you can take to recover and give you a mental model of sorts to get started so that it then helps you to start assimilating the kind of knowledge that you need? And also how to mitigate these errors with some future steps and things to ponder over and think and take away. So first things first, let's set the ground, foundational. The thing is, culture always trumps everything, right? As much as you want to adopt the technology first and then try to put that through your organization, it's all about the way you work, right? And the way you deliver applications to your users. And one of the things that we see with technology, especially with things like Kubernetes, is that it aligns a lot with the kind of advancement we want to have with our organization. Be it from a DevOps perspective where you want to streamline your application deployments all the way down to the kind of technology that's being used by developers so that they can deploy to Kubernetes. The other thing is that you see this in practices like GitOps being the norm, more or less. You see this in infrastructure automation using CDK, CDK8S, Terraform, and so on and so forth. Now, along with any technology that you adopt, you also start realizing that, as much as the technology is accessible, you still need to provide some form of guardrails, right? So you need to have least privilege access. You need to have trust, but at the same time, not trust, right? As much as possible. And with 2023, verbosity is a problem. As much as we all love coding in our own languages, I'm sure everyone over here identifies as being a YAML engineer. I don't know who doesn't, but we all do in some form or the other. And with Kubernetes, there's a lot of things that's been changing, right? Since 2015, ever since it came into vogue, right? And it's been there, it's been adopted, and we see that a lot is happening. But as you'll see in the demo, our demo is also filled with YAML files. Now, this is important because with Kubernetes, it has become a suitable platform as a choice for deploying your applications, right? And applications come in different shapes and sizes. Gone are the days where you used to just build a simple, like a client where you would have a big client, and then afterwards you would just have that connecting to a database, and then that's about it. You have distributed systems coming into the norm now. You have microservices happening, but you also have monoliths still, right? Because it's an architectural paradigm, and it's also because of choice. Beyond that, you see that with failure modes coming in, because apart from your application throwing errors, now you also have things happening within your cluster, where errors would happen because of various reasons, as we're going to see. And things fail in different ways. The thing is, this failure also has an impact downstream, right? This could be within the application ecosystem that you're building on the platform, or also down all the way to the business, where this failure domain overlaps with the business domain. And the thing is, you need to realize what you're operating with. This is a 30,000 feet view, 35,000 feet view of the different moving parts in Kubernetes. I'm sure anyone who has built with Kubernetes has seen this, right? On the left side, you have the control plane, where you have all the requests that are coming in from probably the command line or wherever else that you're issuing it from, which is coming into the control plane. And then you have the data nodes on the other side, the data plane on the other side, where you have the nodes, where your applications actually run, and then they execute. And with all of these components in play, you kind of realize that there's a lot of places where things could go wrong, right? With requests going in over here and things are not working, a massive list of errors that could actually happen on the platform itself. So we'll start with our first polling, just to understand from all of you who are here in the session, which component of Kubernetes do you find the most challenging to troubleshoot, right? So take out your phones, scan the QR code, and select a vote, and then we're going to just see the results in a bit. I'll give you some time. All right, so we're good. And that's the votes. It's still coming in. But as we see that we have, I mean, if you just take config maps and secrets and pods, that's most of the crowd over here already. We have a couple of folks with controllers. I usually see it myself personally with services, but of course, I mean, your mileage may vary over there. But yeah, with pods, a lot of that happens, and you're going to kind of see that as part of the scenario that we're going to be showing in this bit. All right, cool. Let's switch back. Thank you. Right, so let's set the context, right? And the thing is with Kubernetes, a lot of times when we start adopting the platform, when we start adopting Kubernetes, we look at the whole plug-and-play approach, right? We say, OK, fine, so I can take Kubernetes, then I can start plugging in things, I can have Helm charts, and everything works. Well, the plug-and-play approach is a bit simplified, I would say, a more simplistic approach of what actually Kubernetes does under the hood. It is important to think that Kubernetes is actually an application platform, right? It helps you to understand, and this is kind of like a mental model that I usually have as part of Kubernetes. It's a virtual data center in a box, right, without the physical hardware. So you can go in, you can change the way the networking works, change the way pods come up, and your applications are created, how other resources are provisioned. So you want to look at it from that angle. And the moment you do that, you start realizing that it's way more than just plugging in certain components in and then just making it work. Now, the thing is, with applications growing at a large, rapid pace, you see global scalability also coming into being. And when it's done right, Kubernetes is an excellent choice. With the idea that you need to understand the failure domains, right? You need to understand, OK, the more I scale, the more I spread out my applications, the more the failure scenarios increase, right? And that's kind of like as a mental model you need to have in your mind. And when you want to optimize your development practices, you want to ensure that it works really well with Kubernetes. So things like a central code repository where you can pull down your applications and then build that and then deploy that as on your pods, all the way down to thinking about abstractions on top of Kubernetes, right? So if you've ever delved in or already are working on platform engineering, we see this a lot with customers these days, a lot of conversations that are happening where they are trying to build an abstraction on top of Kubernetes because Kubernetes is great at solving a lot of the management side of things, right? From an infrastructure perspective. It abstracts a lot of the infrastructure from you, but it also provides certain things that you would want to abstract from your developers. So a lot of that is happening, and it's an evolving space, and we're probably going to see more conversations around that in future sessions also and during this week at reInvent. The thing with abstractions is that it works, and it works really well, especially when you have good tools, processes, and mindsets. You really need to understand how these things fit together. It's not just about taking an abstraction and then putting it in your infrastructure and then saying, OK, now we have abstracted everything, everything's awesome. Right? So it's always a continuous journey, and it's something that's always going to evolve based on the practices that you have within your organization. And this is kind of like where you start seeing Kubernetes. I mean, as much as we introduce Kubernetes to someone who's new to it, oh, it's a container orchestrator, we all know it's way more than just that, right? It's way more than just an orchestrator for containers. Now, Kubernetes is complex, and probably in your organizations and in teams that we have seen also with customers is that a lot of myriad of tools start coming in where we want to manage Kubernetes. What you're going to see today is a lot of what we're going to be doing in terms of the demos and scenarios is just using kubectl, right? And I pronounce it that way. I'm not sure how many of you pronounce it in the other way, which you're going to see. Me and Thiru usually have that banter about the pronunciation. Now, the thing with kubectl is it's a CLI to perform REST API calls, right, to the Kubernetes control plane. And that's kind of like where you issue the commands and then you interact with what's happening under the hood in Kubernetes. And kind of like with troubleshooting, it's a very, very iterative approach, right? Something crashes, there's a loop because it's crashing and it's checking again, and then you start doing back off because you want to make sure that the failure doesn't impact everything else. You're trying to reduce the blast radius, and then so on and so forth. And that's kind of like how you want to look at it, right? Now, when you want to think about troubleshooting, you want to have a mental model of sorts. And this is kind of like how we do it in AWS, and you would have seen this in some form or the other outside. The idea is that you want to first look at what's happening, and then understand what's actually going on, right? You actually go in, and then afterwards, you look at things, the way they're operating, maybe look at the logs, for example, and metrics and traces. You want to then do what is required to solve the observed problem, and then fix it, right? And then it becomes a continuous loop, because you then look at the next best thing that's going to happen, and then afterwards, so on and so forth, which basically means you are observing, and then you're orienting yourself to what you need to fix. Then you decide what you have to fix, and then you act on it, right? And then you fix it, and then afterwards you keep moving forward. So with Kubernetes as a perspective over here, we see 5 pillars of failure surrounding these domains, right, within Kubernetes as a general observation, especially with customer conversations that are happening every day. First of all, you have like manifest errors. This is things like with the API calls that happen to Kubernetes through kubectl, for example, when you are actually applying the manifest files, the YAML files, like I said, YAML engineers. It's interesting to work with. But did you also know that kubectl also accepts JSON? How many of you actually use JSON with kubectl? All right, cool. All right, thank you. So we have one. But the thing is, with files and with manifest files, there's a lot that's happening, and you want to make sure that the files that you write are syntactically approvable by what kubectl can do. Next up is networking in Kubernetes, and this is the most complex side of Kubernetes. And I think that's also one of the feats that Kubernetes has achieved, that it abstracts a lot of the networking from you as long as things work, right? And the moment things don't, that's when you start going under in the grass and the weeds, and then you start figuring out what's actually going on. I see some nods over here in the audience for that. And this is kind of like where you need to really understand CNIs, for example, right? Container network interfaces, and then you have things like misconfigurations that could happen. I mean, even if you use a managed service, you could have that misconfiguration in the storage side of things because you did not select a certain storage driver. But if you're running your own Kubernetes cluster, this could be things like the control plane is not configured in a certain way, right? And there's always DNS, right? Something always goes wrong, and if you've checked everything else, it's probably the DNS. You should probably check that. Right, so with that, let's go into our second poll. And again, pull out your mobiles and just answer this one. Which type of Kubernetes issue takes up the most of your troubleshooting time? And we're going to see how much of that aligns with our demo right now. All right, sweet. So we're having the results come in. And networking issues, nice, all right. That's fun. Yeah, so networking issues, definitely. We can see the complexity in that happening. Failed deployments is another one, and we see that quite a lot, especially when you are packaging applications together, and then you kind of realize that dependencies did not happen the way it was supposed to. We do see nobody's mentioning security, so that's an interesting one. But yeah, so that's kind of where we see networking issues is usually what is a common thing over here. Cool, let's move on. Thank you. All right, so let's start diving a bit deeper, right? The first thing you need to realize is that the kind of tooling that you use and the way you interact with your Kubernetes cluster matters a lot, right? And what happens under the hood is going to kind of decide how you're going to orient yourself to fix certain things or to find out what to actually fix, right? Now, when you interact with the Kubernetes API, this is basically what happens. On the left, you have kubectl, right? You do an apply or a create first. What it does is it first checks if you're able to communicate with the cluster given the configuration file, right? So you give a manifest file, it'll check what it can actually connect to. You may get an error right outside the gate immediately if it is not configured properly. So that's the first gate over there that you're going to check. Next up from there is that kubectl is going to pass the YAML file, and then it's going to figure out which HTTP paths to talk to. And this is basically where it submits the API calls, right? So it needs to figure out which ones to do it and in which order. And now because with Kubernetes, it's a desired state configuration where you tell it, OK, this is the state I want you to be in. Kubectl just simply submits that request, right, with the YAML file to the API server and then exits. And that's about it from there with kubectl. Now, unless there are issues with the YAML file, kubectl doesn't actually tell you beyond just checking the syntax of, like syntactically if everything's fine, which leads us to the next phase of running the application, which is the API server, right? It has the manifest file and what it needs to do, and then it figures out what it needs to do and then sends the request. So it sends the request to kubelet, which is there running in every node, and then after that, it reports metrics back and then statistics over to the scheduler and to the control plane. Now, because of the complexity of this thing, there's a lot of places where things can go wrong. And we're going to kind of like see that soon. Now with schema and YAML validation, there is scope creep, right, in some form or the other. As much as we start trying to keep it simple, we start seeing long YAML files coming out, trying to add a lot of things to make it work. This is what a typical manifest file looks like. And in this case, it's a deployment resource. And if you have worked in Kubernetes quite a bit, you may realize there's something wrong in this, right? When you're trying to do an apply, errors start coming in. And you get kind of a lot of errors, which you wouldn't realize would have come in the first place when you wrote this, right? Because you would have had to create something beforehand itself, before coming in. How many of you have got bitten by the namespace thing on kubectl? All right, fine. Okay, a few. The rest of you, oh, awesome, thank you. All right, sweet. So with that, we're going to have Thiru start going into the next set of things on how we're going to get started with observing, and then we're going to dive directly into the demo.
Thank you. Thank you, Faz. So hello, everyone. The next part of the session, I'm going to be talking to you about, as Faz said, errors that happen within Kubernetes. And first up, I want to talk to you about best practices with creating schemas and YAML. How many of you have used the dry run flag with kubectl before? And there we go, kubectl versus kubectl. So I really like using the dry run flag. And some of you may already know that there are two ways of using the dry run flag. One is the client, and the other one is the server flag. So especially if you have custom resources, you don't want to use client because the kubectl client does not have visibility over any custom resources that the API server that you've installed on your cluster. And then we also have open source tools like kubeconform. Anyone has used kubeeval or kubeconform before? Okay, excellent. We also find a lot of customers using these tools. And then one of the things that I particularly like, but I also find very confusing, is validation admission webhooks or validation admission controllers. You use them to sort of admit or deny specific schema or manifests to that cluster before the cluster actually starts running your resource. I'm not going to show any of these today, unfortunately or fortunately. But if you are interested in any of these, we're happy to have a conversation with you after. But to avoid all of this, the best way of working with YAML is not to work with YAML. And you can do this by using a variety of different tools like Customize, for example, which is a templating engine that works out of the box with kubectl itself. You can also use things like Scaffold, also another templating and YAML generation engine. On the AWS side of things, we also have things like our CDK, which allows you to deploy resources like deployments or services or whatever through CDK and CDKs. We have a bunch of sessions at re:Invent talking about both CDK and CDKs, as well as using Terraform with EKS. So do give that a see if you've got the time. Helm, I think, is probably the de facto way of installing and running applications within Kubernetes, because you package all of your manifests together, so you don't have to muck about with each individual resource. And if anything goes wrong, you simply download a new YAML, a new Helm chart, and off you go. Okay, so in terms of Kubernetes networking, I wanted to share with you a little bit about things to remember. So CNIs are really important. A lot of the time when you encounter networking issues, more often than not, it's because of the CNI itself. And obviously, with EKS out of the box, we give you the Amazon VPC CNI. Although if you want, you can still install other CNIs as well. Cilium is a particularly popular project these days. And then we also have policy management for the pods themselves in terms of security as well as network policies. The VPC CNI also gives you the ability to work on and provision security groups for pods themselves. So if you have a highly secure environment, then this is also something that you might want to keep your eye on. The most, or at least one of the most common issues that we find customers encountering is IP exhaustion. I guess when we did the slides we probably had the right thing in mind because a lot of you also voted that this was one of your pain points. Maybe I should have included that in the demo, but anyway. Now, moving on to Kubernetes errors themselves, Kubernetes gives you a lot of error codes, but these are not errors in and of themselves. These are just messages that Kubernetes tells you that, hey, look, I can't do what you wanted me to do. And the most common that almost everyone in this room, if you've used Kubernetes before, would be crash loop backoff. And crash loop backoff is, I can't say those words, but it's a royal pain in whatever bodily part that you have. And it's also super difficult to troubleshoot because you don't exactly know what's going on. Having said that, most of the other messages that you see is pretty easy to solve, especially image pull backoff. And we'll look at some of these errors in the demo as well. Now, aside from these major error messages, you also have a random error, which is very descriptive. And again, not unlike a crash loop backoff, it's also difficult to troubleshoot. Then you also have things like pods that are running, but they are not ready. And pods also can be scheduled, but they are not running because they will be showing up as pending state. Has anyone encountered pod not ready issues before?
Okay, a few.
Okay, awesome. So Faz alluded to our troubleshooting loop earlier. And the first step in the troubleshooting process with Kubernetes is to observe what you have. And as we spoke, I'm going to be using a lot of kubectl in this presentation. So the first thing you want to do is kubectl get whatever resource that you have, whether it's a node, deployment pod, or whatever. And I also like to use the OYAML or the OJSON argument as well. So this dumps the entire manifest that's stored on, or at least the current state of your resource that exists inside the cluster as a YAML manifest. This gives you additional information that you don't typically get if you simply run kubectl get whatever. So I like using that, and then if you are also good with JQ, then you can pass it through JQ and get exactly the messages that you want. I also like to use kubectl events or get events. And in this example here, I'm sorting or filtering events that only have backoff in them. You obviously can do whatever else that you want, and we will see some of this in the demo as well. My favorite part of troubleshooting, not that troubleshooting is nice at all, is using kubectl logs. So kubectl logs tells you almost everything that you need to know about what is going on. And in this example, it's kubectl logs against the name of the pod. So another thing you need to remember is for you to get logs, you either need to specify the name of the pod or some sort of selector. So if you have a deployment resource, then you need to specify the particular selector that that deployment has. And here, in this example, it's tailing the last 10 entries of the log, and you can also do a -f or a -- follow to continuously monitor the log stream. And one of the other things that I have been using with troubleshooting Kubernetes is this open source package called Stern. Has anyone used Stern before? Oh, nice. Okay, awesome. So Stern is really nice. It gets you away from the trouble of kubectl logs, but if you don't want to install anything else, kubectl logs works just fine. Right. Now, let's go on to the demo. I sacrificed my breakfast to the demo gods this morning, so I hope it works. So what I'm going to do is I'm going to run a very simple Python application as an API. I call it Cake API because it pulls a bunch of cake names and sizes from a DynamoDB table within AWS. It's extremely simple, and it just exists for the purposes of running an application. So I'm just going to go simply through the code so that you have some sort of idea. I've got several parts for this application. So the main part is /cake, So if you call /cake, it will give you a bunch of cake names, and it's a very simple schema here. And then I've also got a health check path and a random unhealthy path to simulate an error. Okay? Now, the first thing I want to do is run through this YAML manifest. So at first glance, this YAML manifest looks just fine. Yeah, at first glance, this YAML manifest looks just fine. And there are some issues, but we will look at what those issues are as we go along. Okay, so I'm going to try and run this. And, oops. That's the new Code Whisperer CLI, by the way. So since it was recently announced, I haven't actually gotten used to using it. It's still a mental model change to get Gen AI as part of your workflow. But anyway. Okay, so once I do that, I already have a whole set of commands here that I want to run. So here, when I run kubectl events against the Cake API namespace, you can see that there is a service account that's missing. And if I go back here, kubectl submitted the job, but there's clearly a big issue, right? So it's not going to be able to parse through the file and tell you exactly what happened before submitting the request to the API server. Okay, so give me a sec. Okay, anyway, let's go back here, and I want to try and fix. Okay, so with the second YAML file, what I've done is I can show you a diff.
Top.
The thing? Oh, it's not here. Okay, never mind. Sorry. Yeah. So the diff is in the second one. I have updated the service account name, but even with that service account name, I actually don't have the service account created yet. So that's what I'm going to do. And what this little script does is it simply creates a new service account using this command line tool called EKSCTL, attaches it to a particular policy called DDB access policy here. Don't worry about the errors, it will still work, said everyone ever. The policy exists, but the service account within the namespace didn't, so that's what I did earlier. So now if I try running kubectl apply, and go back here, I should have a container creating now, but we have an image pullback off error. So the image pullback off error exists because that does not actually exist in the container registry that I have prepared earlier. So if I go back here, you can see that I've got everything else, but I don't have that. So that's what I'm going to do next. And
just clear it.
Sorry?
Clear it. It's getting cut.
Oh,
yeah.
Okay. Oops. configured. And here, it should create the container. As you can see in the events, it started the container. The container is running, but we're not out of the woods yet because the person who developed the demo has put in a bunch of yeah. So there's no logs yet. So I'm going to see why. If I go open my fix image name, it's because this table doesn't exist. So because that table doesn't exist, the Python code in the container is not able to, yeah. I'm going to use Stern instead. And like I said, I sacrificed my breakfast, but maybe I should have eaten it. So I'm going to use Stern here. So Stern's going to pick up that pod that was just created. And then I'm going to go back here and look at the pods. And I am going to go back here and look at the events. Right, OK. So you can see on the bottom right-hand pane that there is an access denied exception because the IAM role that's attached to the pod. Let me maybe take a step back. Does everyone know what IRSA is, IRSA, IAM roles for service accounts? So IAM roles for service accounts give you an IAM role, an AWS IAM role attached to a service account within the namespace. And you can call this service account in your deployment or pod. And what Kubernetes will do is it will call AWS resources using that IAM role that's attached as an annotation within the service account definition in Kubernetes. Okay? So in this example, that service account doesn't have access to this DynamoDB table. But if you look carefully, the DynamoDB table doesn't even exist. So this is another example of an application error itself. And you can also see on the bottom left that Kubernetes is really, really unhappy. It's crashing, it's backing off, and looping nonstop. OK, so I have yet another YAML that fixes the table name. So now the actual table name is called cake type. So if I go back and go to apply and go back here, a new addition to our troubleshooting journey is the service. So here I've also added a load balancer. And now you can see that the application is running. It managed to communicate with the table. And you can actually, for all intents and purposes, it would work, but for the fact that both the readiness and the liveness probes are failing. So if I take you back to the YAML file here, right, my liveness probe is curling localhost. And if you remember in the code, I don't expect you to, but the code doesn't actually have a path for the root of the application. And the same goes for the readiness probe as well. So I've got yet another YAML file, surprise, that fixes this. But maybe I will skip through that, and then I will go straight to the fixed probes because we're running out of time. And here you can see that kubectl tells you that this object has changed, but the service object remains unchanged. Now, this happens when kubectl gets the last applied configuration from the server. So what it will do is if it sees a similar object being applied, it will verify it with the API server and understand what the configuration of the last applied resource was, or rather, what the last applied configuration of that resource was. And if there was a change, it will assess whether it's a newer version or an older one, and then update the server side of that, and then it will tell you that, hey, look, I've configured it, and in the case of the service, it has been unchanged, so it remains unchanged. And if we go back here, we now have a running container, because the pod, the readiness probe worked. This is the older pod, so you can ignore that, but the new pod is running, and it is getting health requests from Kubernetes itself through the readiness probe. Okay, so excellent, that works. Now I'm going to try and see if I can curl it. This should work, but it won't, because you can see here that it actually crashed. It should have shown you an OOM killed error, but maybe I'll try something else. I'll try this text UI called K9s. Has anyone used K9s before? Oh, okay, nice. So I really like using K9s because, yeah, I can't get enough terminal in my life, so I really enjoy using K9s. And this is a really good utility because it gives you at a glance what's happening with your deployment and your resources as well. So let me try this again and go back to K9s, and it should show us that it was an killed. Yeah, there we go. So it got killed because in my code itself, what I've done is I have created a large Python list that expands to a big field, a big amount of data simply with the first request. So the moment you hit the endpoint, it will create a large amount of dummy data, put it inside the list, and the whole application will crash. That would not be an issue, but in our resource list in the YAML manifest, I've given it a very small amount of memory. So and this is something confusing as well for a lot of people, right? The difference between what a limit is and what a request is. So a request is something that the container asks for when it first starts. So if you anticipate that your container is going to expand as time goes on, then you want to put like a lower request, but you want to expand the limits and not the other way around. Because the request, as I said, is the first, and then the limit is the absolute end of what Kubernetes will allocate to that particular pod. So this performance tuning is particularly important when you're going to be running at scale. Right, and so I'm going to fix killed by doing more YAML. And what I've done is I have changed this to a lot more resources. It's still the same code, but it's a lot more resources. So it should work now. Or at least I hope so. And you can see again that there are more containers that have been started up. And the service object should be the same. So I'm going to try and see if I can get this. And if it works, well, it should work. Yeah, the other one hasn't started up yet. So this is the new one. OK, there we go. So this is data that's pulled out from the DynamoDB table. So we eventually got that. Now, what I'd also like you to do is I have a QR code for you that I'd like you to hit. So this QR code points you to that load balancer, and if everything works, we should see a large amount of auto-scaling. So if you hit it, yeah, I should be seeing a lot of requests coming in, and concurrently a lot of pods scaling up as well.
It's not working for everyone.
There's definitely a lot of requests. And you'll notice that there are still a lot of killed because, as I said, my actual application code didn't change. I simply increased the limits. Yeah, this is something I didn't quite anticipate as well. But it should scale up at any minute. No, come on. Okay, then maybe it didn't scale.
Just kill.
Yeah.
Just kill the pods.
Yeah, okay, it didn't work. Oh well. Right, that's fine. The idea was for you to see that the horizontal pod autoscaler was kicking in and scaled up the pods. So obviously, this is a troubleshooting Kubernetes talk. I anticipated failure, but I prepared for failure, and clearly I was very mistaken. So this is a real-world example of how your Kubernetes troubleshooting journey could also be. So you're not alone. Right, now let me go back to our slides. Okay, oops. Yeah, so we saw outputs from kubectl get events. We also saw outputs from things like get deployments and so on. So these are typical error messages that you get. Now, just to recap again, I've prepared a list of the common issues that you would have. So for image pull errors, it's more often than not a permissions issue against your container registry. So if you're using ECR, Elastic Container Registry on AWS, it's probably because the node role does not have permissions to pull the image from ECR. So that's something that you want to check. You also want to check if your URI and the tags are correct. And then for crash load backoff, it could be anything. So the first thing you probably need to check is configuration. So environment variables, secrets, config maps, and so on. Create container error can be things like service accounts and even other config maps that you've put in. So you want to check if those dependencies are present. Container, if it's not showing as ready, then it's probably because the readiness probe isn't working. So you want to check that and see if you've configured your readiness probe correctly and if your container actually responds to the readiness probe as well. Sorry, oops. And then we also had killed. So something that I particularly like to use is the vertical pod autoscaler to assess how much resources I want. Has anyone heard, or who has not heard of the VPA before, vertical pod autoscaler? Okay, so everyone. Almost everyone. So vertical pod autoscaler is, as its name would suggest, it scales the hardware specs of that pod. So if you've got a need for, let's say, a full vCPU, then the VPA will say that, okay, this container or this pod needs a full vCPU and so on. So VPA contains a benchmarking option. A lot of users end up using this benchmarking option and not actually scaling the pods up because you don't want to scale the pods up, you want to scale them out and not up. That's usually a better practice. So once you have information from the VPA, you can then pipe that back into your requests and limits, and ideally, you should not encounter killed. I wanted to talk to you very briefly about mitigating the too many pod issues. So with the VPC CNI from Amazon, you need to be careful about the type of node that you use, and you also need to ensure that you specify this option called the max pod args, so the max pods in your Bootstrap. If you're using EKS-CTL to provision those nodes, then you can also specify to EKS-CTL that you want a larger number of nodes, larger number of pods in that node group. And you need to remember this little equation that, that basically says that the maximum number of network interfaces or the maximum number of pods that a particular node can support is the number of network interfaces supported by the node multiplied by the number of IP addresses per ENI minus 1 plus 2. That's super easy to remember. An example is for a C6A2X large node, the maximum number of pods that that instance can support is about 58. There's a full list of this, and I've provided this in the documentation later, but do keep this in mind. Yeah, I talked earlier about pod security groups, and another option for you to mitigate pod exhaustion is also to use the secondary network or another subnet for provisioning your pods. And another thing to remember is that the load balancer controller for EKS is not installed out of the box, so you need to remember to install it if you want to use Ingress. Right, and how many of you run stateful workloads on your Kubernetes environment? Okay, so if you're provisioning a brand new cluster, you need to remember to add the CSI plugins, the container storage interface plugins. We used to have two, EFS and EBS, but earlier this week we also announced the S3 CSI, which allows you to use S3 itself as a persistent volume, which is really cool. That's something that you need to keep an eye out for. Ensure that the CSI add-on has permissions to access these resources. So if you don't, what happens is the pod will get scheduled, but it will stay in the waiting phase, and you don't know what's going on, because even when you go through logs for the pod, it doesn't tell you what's happening. So you need to dive deep into cluster logs to actually figure out that the pod was having scheduling issues because of IAM problems. Another thing is that for PVCs, persistent volume claims, provisioning is dynamic, so you don't need to pre-create anything. Just pick and choose what you want. And in terms of scaling, there are some caveats for both EFS and EBS. Okay, so the next thing I want to talk to you about is observability. So we do a lot of observability at AWS, and in fact for reInvent, you're going to have a lot of observability talks. I've provided a list of those talks at the end. But I do want to call out OpenTelemetry, which is an open source framework for collecting metrics, logs, and a lot of other good information about the performance of your resources. All you need to do is just instrument your applications one time, and then you can export them to any number of destinations. And because this is reInvent, we have our own version of OpenTelemetry called AWS Distro for OpenTelemetry, which works really well if you have AWS monitoring resources like Amazon Managed Prometheus or Amazon Prometheus or CloudWatch or whatever else, X-Ray, for example. And ADOT looks a little bit like this. This is the 35,000 feet architecture of ADOT. So you've got a Kubernetes controller that's on the left, And you've got the collector, which is provisioned by specifying whatever manifest that you want. So this is installed as a custom resource via a Helm chart, or you can also install this as an EKS add-on, which I'll show you in the next slide. So once you provision the collector, all it does is it listens to metrics that are published by your resources and then exports them to a variety of different destinations. And because it's AWS supported, out of the box, it works really well with things like X-Ray, CloudWatch, and Prometheus. So this is new. We announced this, I think, a couple of weeks ago, where you can install both AWS distro for OpenTelemetry as well as the brand new CloudWatch observability feature, which installs things like FluentBit and other log collector tools without you having to provision them yourself. It's a managed add-on, so upgrades are also provided for you. And yeah, we have the time. So I'm going to see if I can do another demo.
Switch.
Yeah. So what I've done is I've already enabled cluster logs. So again, when you provision a new EKS cluster, you don't have cluster logs enabled. So it's something that you need to provision yourself or enable yourself. And we now have this new observability tab within the cluster console in EKS that allows you to enable control plane logging. And again, this is a brand new feature. We just launched it a couple of days ago, where every new cluster automatically has the Prometheus scraper installed when you create the cluster. So if you don't want to manage it on your own, every time you create a new cluster, Prometheus metrics are already available for you to simply export. So the scraper already comes pre-installed. So I've done this. And if I go to CloudWatch, I have a new log group for my cluster. And I've got a whole bunch of logs here as well. And if I go to Logs Insights, I can ask, again, this is brand new. Again, generative AI in CloudWatch, which helps you to create CloudWatch queries using natural language. Can you give me?
You can ask nicely.
Yeah. Can you please give me a query to show me cluster errors in the Cake API namespace? And let's see if this works.
There you go.
Yep, there we go.
Cool.
Gen AI works. So yeah, this is an example of how you can use CloudWatch to also query for cluster logs. I also had some pre-prepared cluster queries as well. Let's see if those work. Yeah, those are obviously a bit of a different format, but the idea is still the same. You can get, this is not an error, this is a completed request, but we can filter for errors as well. Now, I want to go back here. Oops. I want to go back here. And I have an
Install dot.
I have a script that automatically installs both the A-dot collector, the A-dot add-on and the CloudWatch observability add-on. So you can do it from the console or you can do it from the command line. I've chosen to do it from the command line. So it should take us a couple of seconds. Yes, no, it's not working. but at the very least, we should have our CloudWatch add-on here. Yep, so I think the CloudWatch add-on is already installed. In fact, the OpenTelemetry one is also installed. So if I go back to CloudWatch here, I should now have a new log group that tells me from Container Insights. So I've got a whole bunch of logs here from my Cake API pod. So here you can see that this is the log output from the health check from Kubernetes itself, again, directly available for you in CloudWatch with very little effort. And you can also do this as well. So we've got this new enhanced observability from Container Insights, which looks a little bit like this. And it gives you metrics out of the box as well. And it's very new since it was just provisioned, so you're not going to get a lot here. But if I go to workload, I can see here that I've got my Cake API pods, and now the stuff is coming in. So we've got Cake API. Okay. Why isn't it working? It should work. Right. Sorry about that.
Time, 3 minutes.
I've got 3 minutes. Okay. Yep. Maybe I'll go back to my slides and finish this up. Okay. Sorry. Again, demo gods definitely didn't work this time around. On top of this, we also have the observability accelerator for Terraform, which is a set of Terraform scripts that will automatically install ADOT. It will install FluentBit, and it will also install Amazon managed Grafana. So it gives you an end-to-end observability solution simply by running a bunch of Terraform scripts. And yep, that brings me to the end of the presentation. So I want to talk to you a little bit about some some final words. Remember to architect your applications in a cloud-native way. So what this means is using small, dedicated services that do one single thing and do that really well. You also want to utilize and understand things like Kubernetes primitives, like deployment services and pods really well. You want to think about using GitOps for your infrastructure, because GitOps allows you to roll back your infrastructure to a point where it used to work alongside your application updates also. Consider using control planes. So control planes are things like AWS controllers for Kubernetes, Crossplane, Gloomy, those sorts of things, where you can provision all of the infrastructure required for your application directly from within Kubernetes itself. Please also remember to implement things like retries within your manifest itself. Earlier, for my liveness and readiness probes, I had a very small retry limit, which meant that by the time the container was active, Kubernetes would already restart the resource. And obviously, that would result in a continuous failure. Be aware of any breaking changes in your custom resources when you're creating manifests. As I said, think about requests and limits. Avoid hard-coding dependencies. Use config maps or secrets for any sort of configuration management, like environment variables and so on. Remember to use IRSA, IRSA, but you don't have to use IRSA anymore, because we've got this new thing that also we announced called the Pod Identity Add-on, which again came out earlier this week. So Pod Identity Add-on allows you to use the same IAM role across multiple clusters. When you do troubleshooting, please also remember to use the OODA loop, or at least some version of the OODA loop, as long as you observe and then figure out slowly what to do. I think you'll be good. Metrics are not logs in themselves, but metrics, when used correctly, can be very, very helpful to understand what's going on and to perform troubleshooting as well. So with that, I have 3 seconds left. Please go see these talks. These are really nice. I've curated them. You've got some additional resources here as well. Yeah, feel free to take a picture. The middle link gives you some documentation and additional reading material. Okay, and with that, thank you very much for your attention. I hope this was useful.
Yep.
And these are our socials. So,
and
thanks.
yeah, please do provide your feedback.